Different DLT platforms have different approaches to smart contract development. Wave smart contracts are represented in three different forms: smart accounts, smart assets, and dApps. We'll practice using smart assets later in this course. For now, we're going to look at smart accounts and dApps. So any Waves account can be converted to a smart account or a dApp by applying a script. A script is program code written in Write, which was developed specifically for Waves. So first, accounts. An account script contains a set of conditions that allows or prevents different types of outgoing transactions. Only outgoing transactions, not incoming. Right now, there are 16 different types of transaction on the Waves blockchain. Some of them are for sending tokens, some of them for storing data, others for deploying smart contract code. You can find descriptions of these 16 different types of transactions in the link below. The creation and deployment of smart contracts for smart accounts has several stages. These include writing of write code. I think this is the most obvious part. We have to write some write code to deploy it. As a next step, we have to compile that code. So there is a compiler which will take our write code and compile it to another representation. Using that compiled code, we have to generate a set script transaction. So we will get some JSON with different fields, and one of those fields is a script, compiled version of the script. After that, when we have that JSON, we have to send it to at least one node, and that node will validate our transaction. Only if validations are done, only if everything is correct, this node will send it, will propagate it to all other nodes. And eventually, at some point, the next block producer will add our transaction to the block. More accurately, there are actually several additional steps. I just described very high level. Now, I'll try to go a bit deeper. First, as already said, we have to write code. After that, write compiler will validate the write code. If you use an online IDE or Visual Studio Code extension, there is a compiler which validates the code, and only if everything is okay, the write code is compiled to an abstract syntax tree and some metadata, and all of this is represented in base64 encoding. As a next step, we have to create a set script transaction, and that set script transaction will contain our compiled version of contract, and we will send that transaction with compiled code to a node. That blockchain node will check the serialization and syntax. It will check, for example, names, variables, and function invocations. If everything is correct, everything is okay, that node will calculate cost. So it will calculate the complexity of the script. And also it will check the signature. After checking and validation is completed by that first node, the set script transaction is passed to the internode's UTX pool. And only after that, all other nodes verify the performed deserialization and computational cost steps. So after this point, we will have our transaction in UTX. And at some point, eventually, mining node or block producer will take that transaction, carry out the decentralization and computational cost checks again, and after that, it will put the transaction into the block. When block is created, that node, the block producer, will propagate this block to all other nodes. So after receiving a new block, all nodes perform the deserialization and computational cost steps again. So we can say that validations and computational cost calculations are performed 3 times for every transaction. Well, after all these steps, the script is executed on all nodes, all participants check the transaction. After that, we will have a smart account instead of usual account. So, smart account script allows or rejects certain outgoing transactions depending on specific conditions. This logic depends on several data sources. We have at least 3 types of data sources. First type, it relies on some account data storage. So there's some data for every account. So every account has its own key value storage. So a transaction, the set script transaction and the contract can check, for example, if there is a value with this key in the user storage. It can check that value. Another type of data we can check in the transaction, in the write code, is transaction data. Let's say we can deny transactions to a specific recipient. We can do that. And also we can check some blockchain state and data. For example, we can reject transactions before a given block number. So every block has a number in the chain, so we can say that transactions from this account are valid only after this block number. So, what is the difference between a standard account and a smart account? To send a transaction from a standard account, you only have to provide a correct signature. In fact, a standard account has only one signatory who can use his private key or seed phrase to sign all outgoing transactions. No user can sign transactions from a regular account that doesn't belong to them. For example, Bob can't sign a transaction from Alice's account and vice versa. A transaction on a smart account can be executed or not depending on some predefined rules in the code. These rules should always return true or false. And the transaction either goes to the blockchain or doesn't. For example, Alice can set a script on her own account to allow anyone to sign all outgoing transactions. Similarly, she can set a script to only allow her to send a transaction from this account.